Recording number 5 here. What I'd like to actually have us do is start off by just talking a little bit about regression as an idea. So if you want to take some notes on this, this would be good. Regression is often talked about in the same wind as correlations, but regression is something a little different. We use regression for the purpose of prediction. Regression is the idea of prediction. When we do regression analysis, we're trying to predict things. There's two types. One is called simple linear regression. Simple linear regression. In simple linear regression, we use one variable to predict another one. We use one variable to predict another one. What would that example be in our snoring example? What would we use to try to predict something else? Beverly, what would it be there? We measured what? BMI and snoring. Which one would we use to predict the other one?
We would use BMI
to
predict snoring.
If somebody was really interested, if you went into a doctor, they would want to know your weight, because maybe weight could predict snoring frequency. So many times that would be a simple linear regression. Let's do one other situation as well, though. Let's say you're going to the doctor and you're trying to figure out who is going to have a heart attack. Is there just one predictor variable there?
Then my legs will be cold.
Would there just be one predictor variable there? Are there a couple of things that could predict? Beverly, I'm going to move away from the phone for just a second. Would there be one variable that could predict having a heart attack? Drew, what would be some of the variables there?
Weight, activity level, sodium level.
Yeah, weight, activity, maybe cholesterol. So that would be a case of what we call multiple regression. That would be multiple regression. So in multiple regression, we'd actually have a couple of predictor variables trying to account for a DV. So that's multiple regression. We're going to learn about, at least this week, simple linear regression. And the way I kind of want to get into it is I'd actually like to have us use our data screen. And Beverly, I think you've got this as well. Let's see if we can actually do it on our computer and follow the steps here. Emily, if I can have you, or maybe we can hand it over to Drew. Yeah, let's have you give it a whirl here. Beverly, are you able to do this on your computer? Yep. So let's go up into the usual, analyze, or if you're a Freudian person, analyze, analyze, and then move it into regression. Now the type we do, there are a lot, you could take a whole semester on regression. Which type, Drew?
I'm guessing it's the linear.
Linear regression. Are you showing that, Beverly?
Yes.
Okay, so do linear regression. The question is, what is our dependent variable? Go ahead, Drew.
Snoring.
Snoring is the dependent, and what is it's not really an independent, but it's a predictor.
BMI.
BMI. And let's do OK. Are you able to do that, Beverly?
Yes.
And if you look at the printout from that, it should be the handout. Oh, did I do it right? Or did I not? Yes, I hope so. Yeah, it's in there. I got rid of a few screens that
We only have this.
that you don't want to have. So this is a this is a simple linear regression. Notice what it kind of gives you here, and I put on the outline here. It gives you something called the best fitting line. And so the idea here is the regression. You get a few screens out. Actually, it may even be useful to kind of go over these tables at first, and then I'll go into a little more detail. The first table that you have on your notes is called the best fitting line equation, and I'll get into that in a few minutes. The second table on your notes, it looks like it might be on the next page. Do you see the table, Beverly, called model summary?
Yes.
And then the third table, Emily, what's on the third table, Emily? What is
Nova.
It says the ANOVA. So if you look on what I did, it actually can do, it's kind of a weird ANOVA example, but Emily, what thing did I kind of highlight on that third table? What did I boldface on that?
The sig value, 0.029A.
And if you don't know anything about significance, is 0.029 good news or bad news here?
That's good news.
That is indeed good news. What that number tells you, and if you want to write some stuff down, what that number tells you is that in this example, BMI does significantly predict snoring. That screen tells you that BMI significantly predicts snoring. Woohoo! Could you even write out an F statement for that? You could. Drew, what do you think that F statement would be?
Probably F.
BMI significantly.
BMI significantly predicts snoring episodes. And we could write an F statement.
The F equals.
You'd have with an F, but then what happens next? F, parentheses, two numbers in there.
Freedom.
Yeah.
And the denominator. Degrees of freedom would have been.
What are they here?
1.
1, comma,
And then the denominator, which is. I'm not sure.
3.
Is it 3?
1, comma, 3, F 1, comma, 3.
And then equals F equals. I guess we'd use the end
Yep.
of the table there. It'd be 15.511.
15.511, and then P,
P equals 0.029.
0.029. This tells you that BMI significantly predicts snoring episodes. So that's good news for our researchers. Beverly, is that working for you? Okay, let's go one table back. I've never done it in this way, but I think this might be the best way. Notice what I start off. Beverly, what did I star in that model summary table?
The adjusted R squared.
Yes. You may want to write this definition down. I'll tell you what the adjusted R squared stands for. The adjusted R squared. The adjusted R squared tells you how much the predictor variable accounts for of the dependent variable. How much the predictor variable accounts for the dependent variable. And that sounds really bizarre, doesn't it? Drew's making me a nice bizarre face. Thanks. Beverly, do you have your brow a little heightened as well there?
Yeah.
So the idea, you've got a dependent variable here. What is the dependent variable? What is the main thing we're measuring? The snoring. If you make a little circle, and in that circle there's 100%, there's 100% of the variability of snoring. What this tells you, and this is a better real-world statement, what this tells you is the following. This tells you that if you know somebody's BMI, and you want to write this down in exactly the way I said, if you know somebody's BMI, you can account for 78.4% of the variability in snoring. If you know somebody's BMI, you can account for 78.4% of the variability in snoring. One variable can account for 78% of the variance in another.
Of the variability in snoring.
So BMI can account for 78% of the variance in snoring. This is called the adjusted R squared. Your book calls it the coefficient of determination. It's called the coefficient of determination. Don't worry about writing it out. You can see it in your book. Drew, can I ask you, does this sound good? Does this sound like it's good that one variable can account for 78%?
Comes in handy.
Yeah, this would be amazing to have one variable account for 78%. There's only in this variable 100%. One variable is accounting for 78 of that variability. Is it surprising that that 78%, Beverly, is significant?
No, it's not. No.
It's not surprising at all.
Yeah.
If one variable accounts for 78% of the piece of the pie, that's how we often call them circle drawings and pieces of the pie. One variable is accounting for 78%. That's a lot. And so, of course, it's significant. That's why that one's very important. Comments or questions? Okay, I'm going to stop this tape here because the next one is going to take a little more work. It's the last one we have.